Hey, guys. You guys can hear me?
Yes.
Uh, Okay. Okay, let me start. Start. Wait. It's going to be a big topic today. Okay. I think in last classes I think I covered some diamond problems, multiple inheritance problems. It's a diamond problem that you get. So that one I covered. Prior to that, I covered access specifiers and problems that we see with interview questions which people will ask you based on access specifiers. Okay. So this class we will cover polymorphism. Okay, what is static polymorphism, runtime polymorphism, and some questions on some problems that some examples that we do on polymorphism. Okay. Anyone had any questions from anything before prior to that? Okay, I'll take that as a no. Okay, so we'll uh, we'll talk about polymorphism. Okay, there is a good article that you can find online. So what is polymorphism? Polymorphism. Polymorphism basically means you would try to have a same name, but it would differ. Okay, it would differ the behavior of the function that you call, or the variable or the content of a variable that you might have. That polymorphic variable can vary. Okay, basically we refer them with respect to functions. Okay, so a function's behavior can vary. Okay, based on what? So it can vary based on number of arguments you pass. Like if it's a function, if you are passing more than one argument, okay, the behavior with respect to one argument, the function which what it does with respect to one argument will differ from function which takes two arguments or three arguments. So that different way of behavior, like we would call it like polymorphism. Uh, so that is one part of it. Okay. Now similarly, you will have other type of options, like I think we covered in our class earlier, wherein we did operator overloading as well. So what does operator overloading does is it's like you are assigning some operations, or you are defining your own way of adding two objects of a class. Okay, they all comes under operator overloading sections. Okay, so all these are things that we previously covered, but I'll introduce you again. So types of polymorphism, we can just split them into two things: compile time polymorphism and a runtime polymorphism. So what does compile time polymorphism means? So compile time polymorphism means whatever the functions or the actions that you want your code to do, you can clearly see it during compile time itself. Like which functions will be called, or which operations will be done, whether it is going to do addition, subtraction, or shifting left, or printing onto console. So all these things we can just look at the code and say, like this is going to call this function, and this is going to call this type of additions or subtractions or arithmetic operations or unary operations or any of them. So they all we can identify by looking at the code, and we can call them as compile time polymorphism. Okay, so compile time polymorphism has two things. One is function overloading and operator overloading. Okay, that's what we I think we had. So function overloading means you are going to have a same function. Okay, like you have a function one and again a function one. Both are taking two different arguments. So both of them are going to take two different arguments. Okay, so since they are taking two arguments and the function name is same, right? So you can clearly in your code itself you can clearly see uh, based on number of arguments that are passing, right, which function is going to be called. Okay, which function is going to be called. So these sections and all these are comes under function overloading part. Okay, so for any doubt on this function overloading part? Okay, good. Okay, so the next one is with respect to operator overloading. See, you want me to cover this, like this is already covered in previous classes. I don't want it to mix it up here. Okay, uh, so the other one is op operator overloading. Okay, operator overloading means some of the examples that we saw like addition, subtraction. I think we implemented them like operator overloading or assignment operators. Okay, and plus subtraction. I think what we did shifting left or printing contents of a class. All these things we have done. Okay, they all come as part of uh, compile time. Like so, like plus equal to or division or addition of two class members. They all come as part of operator overloading. So whenever you write your code, right, you can just where is the main in your main itself you can see at the compile time itself you can identify. Okay, so this is going to call plus operations on to my student objects. So I just need to refer this function. Okay, so this is the function which is going to be called. So all this okay comes under compile time polymorphism. Okay, so the behavior also the results also you can actually predict. So what is going to happen? So they all come under compile time uh, polymorphism. So operator overloading and function overloading. So if someone asks you a questions with respect to what is polymorphism, you can just say there is two types of polymorphism: compile time and runtime. This compile time is nothing but function overloading and operator overloading. So all these results we can predetermine or we know the results during the compile time itself. Okay. So the other time, before we end that, any questions on this compile time, function or operator overloading?
The function overloading in the sense that memory what we are allotting for function that is like the memory is not sufficient.
No, 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 no. Function overloading means overloading means see assume this is a function. This is a function name, right? What is the arguments that you are passing here? How many arguments you are passing?
One argument and pass.
Okay. Now here,
Yeah, two arguments.
correct. Now how will so now you have written code here. Okay. In your application, you have written a main function and you are passing only one argument here. Okay.
Yeah,
Here you are passing only one argument. Okay. Now here you are passing two arguments. So
yeah,
when you are writing your code, how would your application or a compiler know when you write this? Okay, it should call this and not this. Okay, and also here you have given a integer, but it's going to call still a double because it's not taking more than one parameter. Okay, if you
yeah,
compile the same code in C, you would see an error here. Like you are writing a same function, okay, with different arguments.
yeah.
Yeah, but you will get an compile time error, like you are redefining the same function. Okay, so that error you will get in C, but in C++ you will not get this. Why? Why? Because C++ uses name mangling. I think I covered this. In name mangling, what it does is whenever you write a function with an argument, right? Let me go to an example. Okay, here you wrote a function. Here, this is a function which returns integer but takes no arguments. Okay, and here this is the same function f which is taking one argument int.
Yeah.
Okay, so when C++ compiler compiles this, right, it sees it. What it does is it's going to give a new name for it. That is internal naming that you will not see it. So it is going to convert this into this. So wherein v says void, v means void.
Nothing.
Void means it is not going to take any parameters. Whereas the second one is f followed by int. So f followed by int. So this is how it will start to give different names for this guy and this guy. Okay. So whenever you are trying to write some code, right, he's going to say function. Okay. Followed by what is it? It's an integer. So an underscore int. Then one more integer underscore int. Like that, he will convert them and try to find a suitable match for it. Okay. All these things happens during compile time. Okay. And this way of adding more than one argument to a function is called function overloading. You are loading over, that's all. These arguments are nothing but your loads. How do you change it? Okay, or over your what should I say? The name it says as this technique or terminology is called as overloading function overloading. Okay.
Okay.
Any doubts on this?
No, 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 nothing, sir.
So this is what it does. So if someone asks you what is function overloading, you should say here the function remains same, function names remain same, but the number of arguments differs. Okay. So now since the arguments differ, whatever the contents inside it will also differ. Okay. Here it's going to print value of x is just x. Here is going to print value of x and y is so on so. Okay. With a comma in between. So these are differentiations that you can achieve in C++, whereas not in C. Okay, in C you would use some pointers, etc., etc., and all. Uh, that using that way you can call in C. Okay, but that's beyond. Okay,
Okay.
so this is with compile time polymorphism. So next comes a runtime polymorphism. The second one comes as a runtime polymorphism. What does runtime polymorphism mean? Is see, you are trying to identify objects or functions during runtime. Okay, objects or compiled. I mean, what is the actual object on which you are trying to call? Everything you are trying to call during a runtime. Okay. Now let's write some classes. Base class. Assume I have written a base class. Okay, I have a base class. Now I have going to derive one more class, derived class. Okay. Now if I create an instance of base class, okay, Okay, so what we are trying to do, we are just trying to create an object during compile time itself. We know this object is of type base class. Okay, so during compile time itself, we are able to identify it is a base class, and you are trying to print the contents of base class ka variable color. Now, what is base class dot color having? It is having black. Okay, it is having black. So if I compile and print this code, it would print black. Okay, now I'm going to call a function by name display here. Let's see what it's going to. So I'm just calling base class display. He is going to call base dot display function, and here he is going to print animal followed by whatever this class name is and end line. Okay, so we'll compile this and see the results. What happens? It's just going to print the. Just build it. So what he did, okay, let me clear the screen. So the result is he printed black, base dot color is black, and base dot display. Base dot display is nothing but animal, whichever. Sorry, okay, I should have renamed it properly. Okay, so it's going to print black and the class name as base class, and whatever it identify, whatever the type of the object that it identified during runtime as well. So during runtime, this you just start out, this means you are not typing it anything here, but whatever that you want to identify during runtime, you are able to print here. Okay. Now this is something which we can identify during compile time, because you have written everything as constants and compiler can see everything, every object type clearly. Now let me create now derived car instance. Okay, let's see. Okay. Now if you see here, derived object dot color. So now if you see, derived class has a variable by name color. Okay. Now derived class also inherits base class. Derived class also inherits base class. So which means base class also has a color. So there are actually two variables with the same name, color and color. So one is for base class, one is for derived class. Okay. Now we will see what it actually prints. Okay. Now before that, let's see what more can we do with this. I'll do that. Let's stick to this. Let's see what is got compiled. Okay. Now you see, uh, when we added the second code, it is able to print gray. It's going to identify derived class, and 12D it is saying the derived class ka name. Okay. So even if we put our pointer here, right, it is saying it is a derived class object. Okay. This is able to identify it during compile time. So all this comes as part of compile type identification. Even here, he is able to identify the objects during compile time. Okay. Now, so far, so good. No problem, right? So because my code is very clear, wherein I have created two variables of base class and derived class, using which I am able to print what it is. Okay. Now I see there are number of lines which are repeating here. Okay. Now I just want to optimize it. Okay. Now I want to optimize it. What I will do is, okay, now I'll write a function print who is going to take pointer, okay, base class object pointer. I think in previous classes we covered saying that how we can use a base class pointer to call functions of derived object. So it can, this pointer, using this pointer I can point to a base class object and also a derived class object. Okay, using this, okay, I would like to do certain operations. Like I just wanted to optimize the code. Okay, wherein I'm going to call, uh, no matter what object you pass, I'm just going to print the color and display that you are that which are part of this. Okay, now I'll comment this code. Okay, I'm going to call print and print. Okay, okay. So you guys are able to understand this part of the code, right? So I'm just calling a print function which is going to take a base class object and derived class object. Okay, and he's just going to call, he's going to print the color. I don't know why this got disconnected within 22 minutes. Maybe Sakale, you joined earlier. Okay, let's resume. Let's. Is there anyone supposed to join? Okay, Subha also joined. Okay, sorry guys. I think someone has opened the meeting even before 8:30, so it got disconnected. Okay, so what I am trying to do here is, let's put the code straight. Let's not confuse you guys. So here I just created two objects, base object, derived object, but I called a same function which is going to take either a base object and derived object and call some functions on top of it. Okay. Now let's see what it does. See, here he is saying base. Okay. And he's going to call a base object. Okay. And we'll see how the results are going to be. Okay. Let's see. See. Now you see the result. Black, base class, base class. Black, base class, base class. Okay. So though we created derived object, what did we do? We created derived object. Okay. It and we called color and display. It should have actually printed whatever the derived class ka color should have, right? Or derived class ka display it should have. That is what what would a programmer think? Like, see, I'm calling a same function. Now a derived class also has color and it also has display function. So I thought it should have it should print the contents of derived class ka variables. So you got what I'm trying to say, right? It should have printed what here gray derived class and 9 derived class or 10 derived class here, but it didn't print. Okay, why? Why is it? Because any idea or any guesses? Okay, I'll explain this in a Excel sheet so that you guys will be able to understand this. Now let's have two classes. Okay. Now inside base class, what does it has? It has a variable by name color and a function by name display. Okay. What is this? Okay. Now, so derived class has a it has its own color and display followed by it has a base class also, right? It has also has a base class. Okay. So now if you see, right, if you see now what we are using here, we are using reference. Okay. Using reference, we are and pointer concept, we are trying to refer the objects and the memory locations. Okay. So what it will do, it is a pointer. It is going to point to the variable as per the pointer type it is. See, what is a pointer type? It is base class. So it will refer the base class distance plus the variable name. Okay. Now, since I have a variable by name obj, I should rename this to POBJ. Okay, that's a right naming convention. Now I have a pointer by name POBJ. Okay. Now using this pointer, okay, you are trying to access color of a base class, so it will directly point to here. Now, now using the same base type pointer, you are trying to access the contents of derived. Okay, access the contents of derived. So now what it will do, instead of going here, it is going here and printing. Okay, I'll put an arrow. Yes, okay. Similarly, if you are okay, so why this is happening is you have a base pointer. Using base pointer, compiler would like to identify, or it will calculate, the compiler will calculate only the address within the pointer's reach. Whatever the pointer can reach, only to that he can uh, reach, and he will call only those functions or variables. It can access only whatever the pointer's capability. What is the pointer's capability? Pointer capability is nothing but it can reach to base class ka objects within the derived class. Okay, am I clear this on this, right? Since we are using base class pointer, okay, it will only point to the base class objects here. Okay, base class contents, which is part of derived class. Okay, that's the reason he is only able to call color and display. Now, how do I call this variable and this variable using a pointer? Using a pointer, how can I call this and this? Since it's a base class pointer, it is only having access to this. Now, since it's a derived, if I make it a derived class pointer, will I be able to call this? Okay, we'll see this. Okay, we'll try to see what we can do. Okay, now let's see which function this is trying to call. See, I just added a function by name derived class. During compile time itself, he's able to identify, he's going to call derived class ka pointer. Let's see what this guy do. So now, whereas on top print, he is trying to point to base class. Okay, if you are passing base object, he is going to call base one. But if you are passing a derived object, he is going to call derived class object. This is similar to function overloading. Okay, this is similar to function overloading, based wherein what type of object you pass, that particular function will be called. Okay, now we'll just compile this and see if it is printing as what we want. Okay, now if you see the result, black base class. So black is the base class variable content, whereas gray is the derived class ka variable content. You see the results, black and gray, black and gray, derived, 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 derived. So during compile time itself, without any much, I mean, since you have added a separate functions, right? Okay, which takes derived class object, it is able to call the actual function which you want, and it's able to print that. Okay, so am I clear on this? Like, it is a function overloading or on a class and all. This is like compile time polymorphism that we are trying to achieve here. Okay. Now we will any questions on this so far? Yes or no? Anyone? Okay, am I audible to you guys? Fine, right? Okay.
Yeah, yeah, yes.
Okay. So using a so common function with derived this thing and all, we are able to call what we want. So this is how you call and print whatever objects that you want, whether you want to print base class contents or derived class contents, you can achieve using this. Okay. Okay. Now uh, comes the tricky part. Okay. See, I have to write two functions. Okay. I have to write two functions so that my exact implementation. Okay, so let's call what is implementation. Let's come to, so this is called implementation. Okay, let's call this function as our implementation. Now if you see, base class has his own way of printing things, or we will call this as display is this implementation. In his display, what he is doing, he is printing his name and something else. Okay, in derived class we have an implementation for display. He's just going to print derived and name. Okay. Okay, to deliver the actual objects implementation, right? To deliver the actual objects implementation, we need to write two functions. Okay, we need to write two functions to do this. But would this be acceptable? Okay, writing, copy pasting and writing the same thing. Okay, this is not something which is acceptable. Okay, is not something which is acceptable, which people don't want. So what they want is like, assume you want one function using which, based on the actual object that has been passed, based on the actual object that has been passed, the actual function gets called on top of it. Okay, so here I passed a base class. So now base class display function should be called. Okay, in the next line I passed a derived class. So now the derived ka what should I say? Derived ka display should be called. Okay. Now how we can achieve this? Okay. Now how we can achieve this? Okay. So all these problems, right? Like with respect to duplicates, I think we had multiple problems with respect to duplicates. One is with destructors. Okay. One was with multiple inheritance. Okay. How we can avoid having multiple instances of base classes, or how we can control creation and deletion of objects. Okay, uh, in proper sequence. So what did we do? We just used a keyword by name virtual. Okay, what did we do? We do a keyword by name virtual. So the moment you add a keyword by name virtual to whatever you want, okay, whether you want to add it to a function or whether you want to add it to a class that you are trying to import, right? So you see, most of this problems that we do or deal during compiling or runtime, right? They all get they all goes out. They all goes out. So this is, see, using virtual, what we are trying to achieve? We are trying to achieve runtime polymorphism. So what does runtime polymorphism means? See, in runtime polymorphism, we are able to we should be able to identify the actual object, and we should be able to call the actual object's implementation. Okay. So I think in previous class, where somewhere in smart pointers and all, I think somewhere I explained virtual keyword or somewhere, I think I don't remember. Okay, I explained the virtual keyword using which why this one the destructors has to be virtual and all. Okay, the same thing we are going to do here. So what we did, we just added a keyword by name virtual here. What did we do? We just added a keyword by name virtual here, and we commented the second function that we added, the print for derived class ka this thing that we added, we just comment. Okay,
In
now
RTTI,
with
you have explained that one. Virtual.
sorry.
The virtual keyword, right?
Mhm.
You have explained in RTTI.
Yeah, we explained in
Many
RTTI
classes, yeah.
runtime. Okay, type identification, how to identify the type during runtime and all.
Yes.
Okay, so how this does, I'll explain this. Okay, correct. So now what we did in this class, we just added virtual keyword and commented this, but we didn't make any change to the application. Okay, now let's see, we'll save this and see what is the behavior here. See, now the moment we did this, right, we are able to see the function that whichever we wanted is getting called, derived class implementation. Okay, you see derived and derived class ka implementation in previous, right, we what we did, we added one more function and we wanted it to call derived class, so on. So, and if you see here, right, the variable is still black. The variable didn't get the polymorphism concept because we didn't add any virtual keyword here. Okay, but if you see here the derived function, okay, we are able to call a derived class ka implementation, derived class ka implementation, okay, with a single function call. Okay, so what we can achieve using this is like we can reduce number of lines of code. We just added one keyword, okay, and using this keyword we are able to reduce number of lines of code. And during runtime, okay, during runtime, based on the actual object type, we are able to call the corresponding implementation of this. We are able to call the corresponding implementation of this. Okay, we'll do an example, like most of the common example is calculating area of a triangle or a square and all. Okay, so far any questions on this, like, okay, I'll just remove the virtual keyword and see what happens. Okay, we just remove the virtual keyword. We'll just compile it again. Okay, now you see it is calling base class function and base class results are getting printed here. Why this is happening? Because the function that this guy should call is predetermined and fixed to base class during compilation itself. Okay, during compile time itself, it got fixed that this guy should call base class. Okay, now that's the reason he's trying to call base class ka function. Now if we add back the virtual keyword here, okay, if you add back the virtual keyboard here, so even if you put your pointer here, right? It is still showing base class function. Okay, because he's going to call this function only. Okay, but when we run, okay, when we run during runtime, the behavior will be different. See, it printed derived class. Okay, but you see the compiler is showing I am trying to call this function. Okay, and display here. Okay, okay, and here if you put, he is saying I am going to call base class ka display. Okay, but it is not calling base class ka display. It is actually calling derived class ka display. So the behavior or the result changed during runtime. Okay, so this concept is called runtime type identifications. Okay, runtime type identifications and all. Okay, now we saw this function got called from derived class, but the variable result is still black. Okay, it's just a variable. Okay, let's see, there are two instances of it. Is there any way can we do this? Let's see, can we do a virtual on a table? See, no, virtual is not allowed. So you cannot have virtual on variables, but we can have virtual on implementations. Okay, so virtual keyword only applies to interfaces, but not to the variables. Okay, that's why you are not able to call it. But by any chance, you want to do something here, like I want to print derived class color, and we need to do something else here. Okay, before that, you guys are clear, right? Any doubts on this so far? You guys are able to understand the virtual keyword, what it does, how it helps us identify the actual object, and will call us the actual function that we wanted based on the actual object type. Okay, now you guys can ask me a question like how compiler will actually implement this. Okay, now you can ask me how compiler is actually implementing this. Okay, how he is calling display of base class and derived class. Okay, how all these things are happening. Okay, so all these things happen. Okay, because of there is something like v pointers and v tables in the C++. So using those, all this gets called. I'll explain you what is v pointer and v tables. Okay. Before that, we'll do a small program of calculating the area and all. Okay. You guys want me to do this calculating the area or something else?
Which area completed?
Sorry.
No, which area completed is square one, circle one?
Yeah.
Which
Let's have some shapes. What are the examples of
which
shapes?
square, circle,
Square, triangle.
Triangle.
or a
Yes.
plane. It can be a shape, or I would say it can be a plane, or we can make it a plane. I take right word is plane because it's on only one side. Okay, we can have triangle and we can have a square. Okay, so what does triangle have? It can have int int of sides. How many sides is going to have? How many sides is it going to have? It's going to have three. Okay, let's see. We initialize them now to 0. Okay, let's calculate the area. So what is the formula for area? Anyone? Assume this is an equilateral triangle. Okay, think half BH or so it's equal to root 3 by 4 a square. Okay, do we need to do root 3 by 4? Okay, let's calculate.
Half BH only, right?
Mm,
The area of triangle.
that
Oh, you have
is
taken the equilateral triangle.
equilateral
Okay, okay.
triangle.
That is, yeah,
Yeah.
yeah.
So let's
That is
make it.
different ones. Means
Yeah,
90
but
degree should be
no, no,
required
it's
for that. Yeah.
okay. Let's not do a equilateral triangle. Let's do a, what should I say? Something which has a 90-degree. What do we call? Yeah,
Yeah, only triangle you can put. That is fine. Only triangle.
yeah,
Yes. Area
base.
of triangle.
That is again getting complex.
Contest. Yeah.
So H.
Mm,
No, no, we'll have.
half HP. This one. This one only.
No, we wanted to have. No, this is for base into height. HB is again. You need
Mm,
to calculate HB here.
okay.
How do you call HB? HB you don't need to call. And we have a triangle with. Okay, let's not do area. Let's do perimeter. That's much more simple.
Uh, or the rectangle.
No,
Or
perimeter of a
else
triangle.
rectangle.
No, we'll do it. We'll do a perimeter, which is nothing
Square
but
you
a
can put.
plus.
Or else.
Perimeter
Um,
we'll do. It's just a plus b plus c. Okay, so we'll do because if you want to calculate area, right, you need to put math like and all. So
mhm.
let's not do it. So you're going to have perimeter. Okay. Now triangle is going to have three sides. Okay. Now perimeter is equal to just simple addition of 0, comma 1, comma. Okay. Now you're going to have a square. Now square is going to have, okay, It's going to have four sides. Okay, but even if you know
So
the
it's,
value of one side, that's enough, right?
hmm,
So it should be 4 into side. This is the
square.
perimeter of your square. Okay, now we'll have a plane.
Shape only you just mentioned. Shape only you have mentioned. Sir. It is good. Shape is under means triangle square. It is under shape only.
Plane.
Shape, right?
No, shape can be something else, right? Shape can be a cylinder, 3D object also. A
Okay.
plane means something uh, which doesn't have full shape, but it will just have sides. So triangles, squares, rectangles, all this comes as planes. Shapes means cylinders, cubes, cuboids. Okay, they
Okay.
all
All
comes as
okay.
comes of it.
All in combination. Yeah.
Okay, now let's do something. Let's write a okay. Now we'll not need this. What we would need just perimeter. You just need to calculate the perimeter. Okay, and just print us. Now what objects that we need to call create triangle or
So your voice is breaking. Voice is
okay,
breaking, sir.
okay. What we are going to create is an object of triangle and an object of type square. Okay. Now what we are going to call just print. Okay, we can rename it. Okay, print perimeter. Okay, let's see this guy is able to print the actual perimeter of this or not. Okay, this is in wrong place. Let me rename this folder. Okay, what happened? Okay, it is printing polymorphic data. He is going to print 0 0. And what did he do? He just called perimeter, perimeter ka plane, stdc out. We didn't initialize anything, right? Okay, sorry, we didn't initialize any of the contents. Now triangle 2 comma 3 comma 4. Sorry. Okay, so with this we are able to initialize the variable sides. Okay, similarly we just need to write one more constructor for square. This is not public. Square. Okay, so what he's going to do, he's going to take the variable name x, and he's going to uh, just initialize its sides. Okay, I think we can make it much more generic. Okay, then for that we would need generic programming here. And that's not. So we have a site 0, site's length is 0. So we'll try to initialize it. Let's give a size as comma 3 comma 4. And what should be the perimeter for this? Let's have 5. Size of a square is 5. Okay, now we are able to create two objects without any issues. We'll just build it. Since we assign some sites, it should give us some results. So now we see the perimeter of a triangle, okay, which has size 2 comma 3 comma 4. If we add it, it should become 9. Okay, and we got the result as 9. Okay, now similarly for a derived object, for a square, it is 4 times the side, 4 into 5, which is nothing but 20. This is what we got. Okay, now how we were able to achieve this, like how we were able to call the actual perimeter. Okay, so of the actual object. See, we were able to do that because we defined the perimeter of the base class as virtual. Okay, we defined the base class perimeter as virtual. So using that, what we were able to do, you were able to write only one function call, which will take plain pointer and will call the just perimeter function, and we are able to calculate the result. I think that's, we'll wait for this. Okay. Now we will see the behavior when we remove the virtual keyword. If we remove the virtual keyword, what will happen? Okay, as per our previous experiments, the runtime type identification property is lost. The RTTI, what is the actual object and what is the actual implementation of it, is lost. So if I call perimeter, he's going to call P of obj and perimeter. Now plain pointer, okay, it doesn't have any virtual function. Since this guy doesn't have any virtual function, what is going to happen? Is going to call just the perimeter of base class. Now, what does it has? It has nothing. Okay, so there is nothing, so it should not print anything at all. It should not even print anything. Let's see if that happens. Did I save this file? Yes, I just saved it. See, it didn't print anything. It didn't print anything. Why? Why? Because the classes triangle and square, they lost some of the polymorphic capability. What did it lost? It lost the polymorphic capability. Okay. Now we can only give the polymorphic capability to them, or a runtime polymorphic capability to it, or runtime type identification property or capability to it by introducing or by making the function as polymorphic. You can just say virtual here. Okay, you can just say virtual here. Now if we compile the same code with some changes, see, now it is able to call the actual implementation which is wanted. Yeah, you are clear on this, right? So far, how we can achieve runtime polymorphism of the objects, okay, or how we can identify the actual object type during runtime, and we can call the actual implementation which has been defined for this function. Now you can say, see, uh, now you added triangle and square, we are, and we have implemented the implementation for them. Now give us a another shape. Okay, line. Okay, let's have another shape by name line, which is just going to take int and copy it. But for this, I'm not implementing the perimeter, or I'm not implementing it. So when I say not implementing means I'm not overriding it. Okay, I'm not going to override it. Okay, so since this guy, in this guy you haven't overwritten the perimeter, he is supposed to call the perimeter of the base class. Okay, he is supposed to call the perimeter of the base class. Okay, let's see whether it does it. Now what should it do? It should print the perimeter of the triangle followed by square followed by line. So in line we didn't do any implementation, so it's going to call, it should call the perimeter of the base class. Okay, now let's see what it does. It did come. It's got it. See, line number 9. I mean, so if you see only two prints, 9 and 20. Okay, and the code got compiled also. What it means is, what we are trying to say here is, see, just because I added a keyword by name virtual, just because I added a keyword by name virtual, it doesn't mean that in every derived class, okay, I have to override it. There is no rule saying that you should override the virtual functions. Always, there is no such rules. Okay, by making by if you have just declared one function as virtual. Okay, you got it right. Any doubts on this? Okay, I'll take this now. So what I meant to say is, you have a function by name perimeter, okay, which you want derived objects to override. Okay, you want, or you can, okay, you want the derived objects to overwrite. So you can add a simple virtual keyword on top of it. So every derived object will have their own implementations of it. Okay, so when they have their own implementation, based on the object type, the corresponding functions will be called. So in our line object, we didn't have any implementation for the perimeter. So, but the code got compiled and it ran without any issues. Okay, but what got executed is nothing but the perimeter function of the base class. The base class perimeter function got called. If you want, I can just add a log here saying that I'm not implemented, implement me, and see does it prints. Okay, let's compile this and see what happens. See, for first two objects like triangle and square, it printed the area. But for a line, we didn't override the perimeter. So it called the previous perimeter, whichever that is available in its hierarchy. So it just called I am not implemented, implement me. So which is nothing but the implementation that we have in the base class, which is plain. Okay, uh, clear, right? Okay. So is this enough, or you want me to give any more examples on this perimeter? We'll cover the V pointer tables and all. Okay, next class. But prior to that, I wanted to see that you, if you guys are comfortable with this, the virtual keyboard, what it actually does. When we go through the V table, right, that's when we'll understand how it does or how the compiler does it. Okay, how the compiler will do it and all. Okay, so in this section, right, okay, uh, there are questions related to abstract class and what should I say? Virtual, pure virtual class. Okay, pure virtual class or interface and all will have it. Okay, there are questions related to what is an abstract class. Let me add a they'll ask us what is runtime. Okay, what is abstract class? Okay, so these are the four questions which people will ask you just on the virtual keyboard. Okay, so we can go through this also in next class. Okay, prior to that, make sure you guys understand this, or you guys take this as an just smaller uh, example for today. Just before coming to next class, I'll go through the same questions again, but I want you guys to uh, find some more information on top of it and come back with some questions on them. Okay, what is like what is runtime polymorphism? What is abstract class? And last, what is a abstract class? And what is a pure virtual function? What is a interface? Okay, all the four are revolving around the virtual keyboard. Just go through them and come back. So We will revise it. I'll revise it tomorrow, so you guys will understand it. What is the importance of this? Okay. Any of you know what does this abstract class mean, or a pure virtual function mean, or a interface? Or have you heard them in your colleges by any chance when you read? Okay, I'll take that as a no. Okay, I'm just printing these questions. Just go through them and come back. Okay. So okay, you guys can go through this and come back. So we'll cover the same thing in the next class as well. Okay. Thank you guys.
Thank you, sir.